Have you ever wondered what would happen if an asteroid hit the Earth today? Ponder on that for a moment. Picture the unimaginable chaos, the catastrophic potential of such an event. It's an age-old threat, lurking in the vast expanses of our universe, silent yet deadly. Asteroids have been a danger since the dawn of time, their destructive power shaping the course of history and life on Earth. It was then that a monstrous asteroid about 6 miles wide slammed into what is now Mexico, causing a global fallout that led to the extinction of dinosaurs. Such a calamity is not just a thing of the past, it's a possibility, a potential reality that could happen again. It's a threat from above, a cosmic bullet in the chamber of the universe's gun. So when did we first become aware of these celestial threats? Our awareness of asteroids began in the early 19th century. The first asteroid, Ceres, was discovered by Italian astronomer Giuseppe Piazzi in 1801. This marked a seminal moment in our understanding of space. Until that point, we believed our solar system was a neat and tidy place with the sun at the center and the planets revolving around it in orderly orbits. But the discovery of Ceres, a tiny world drifting between Mars and Jupiter, turned that notion on its head. We realized that our solar system was more like a celestial wilderness, filled with wandering objects of all sizes. This revelation not only expanded our knowledge of the cosmos, but also highlighted our vulnerability. The realization that these celestial bodies were not just distant stationary objects, but were in fact moving and could potentially cross paths with Earth, was a game changer. Ceres was just the beginning. Over the following decades, astronomers discovered thousands of these rocky bodies, each one a potential threat. Some were small, others were massive, but all were part of a vast asteroid belt, a cosmic shooting gallery that could potentially send a deadly projectile our way. With the discovery of asteroids, the race was on to track these celestial bodies and assess their potential threat. The question wasn't if one of these asteroids would hit Earth, but when. And when that day comes, will we be ready? As technology advanced, so did our ability to monitor asteroids. This isn't just a happenstance, it's a testament to human ingenuity and our relentless quest to understand the cosmos. In the earliest days of asteroid tracking, astronomers would painstakingly chart the night sky using rudimentary telescopes. They'd note down the positions of stars, and over time, they'd notice some stars moved. These wandering stars, as they were called, were in fact asteroids. But as you can imagine, this method was far from perfect. It was time-consuming, relied heavily on clear skies, and the human eye can only see so far. So it was clear that a more efficient system was needed. Enter the age of radar and satellite systems. Radar technology revolutionized asteroid tracking. With it, we could accurately calculate an asteroid's distance, speed, and trajectory, and do it far more quickly than before. Suddenly, we could see asteroids we never knew existed, and we could track them with precision. Around the same time, space agencies like NASA were launching satellites into orbit. These satellites, equipped with powerful telescopes and advanced imaging technology, gave us an unprecedented view of the asteroid belt. They could spot even the smallest asteroids, and they could do it 24/7, regardless of the weather down here on Earth. Today, these satellite systems, like NASA's Near-Earth Object Observations program, continue to watch the skies. They're our first line of defense against asteroids, alerting us to any potential threats. And let's not forget about the role of international cooperation in asteroid tracking. Space agencies around the globe are pooling their resources, sharing data, and working together to keep an eye on the sky. After all, an asteroid doesn't care about national borders, but knowing where the asteroids are isn't enough. What can we do if one is on a collision course with Earth? That's the question that keeps scientists up at night, and it's the question we'll explore in our next scene. When it comes to stopping an asteroid, Hollywood has given us some dramatic solutions. But what's the reality? Now let's talk about the real-world strategies experts have up their sleeves. First up, we have the gravitational tractor method. This technique is all about playing the long game. It involves sending a spacecraft to orbit around the asteroid. The slight but persistent gravitational tug between the two bodies over time can nudge the asteroid off its collision course with Earth. It's like a cosmic dance where the partner's moves are so subtle, yet so profound. Next, we have the kinetic impactor technique. This method is a bit more direct. We shoot a spacecraft at the asteroid at high speed. The impact alone should be enough to change the asteroid's trajectory. Think of it as a cosmic game of billiards, where Earth's safety is the ultimate prize. And finally, we have the nuclear options. Now, this isn't about blowing up the asteroid like in movies. Instead, we would detonate a nuclear device nearby, vaporizing part of the asteroid. The resulting force would push the asteroid off its path. It's a drastic measure. But sometimes drastic times call for drastic measures. While these strategies sound promising, technology has to catch up with theory. So, the next time you see an asteroid hurtling towards Earth in a movie, remember, we've got some real science-backed plans in the works. In recent years, we've seen exciting developments in asteroid deflection technology. Our cosmic neighborhood is a busy place, and humans have been gearing up to face the challenges that space throws at us. One of the most promising advancements comes from the National Aeronautics and Space Administration, better known as NASA. They've been working on a mission called DART, which stands for Double Asteroid Redirection Test. Now, DART is not your average space mission. It's a kinetic impactor technique, meaning it aims to change the course of an asteroid by hitting it with a spacecraft. Yes, you heard that right. We're literally throwing a spacecraft at an asteroid to nudge it off its course. But NASA isn't the only one in this game. Across the pond, the European Space Agency has a complementary mission called Hera. While DART is all about the punch, Hera is about the aftermath. It's slated to reach the same asteroid couple of years after DART's impact to assess the results of our first attempt at asteroid deflection. Meanwhile, in Russia, scientists are exploring a different approach. They're working on a project to use nuclear explosions to deflect asteroids. It sounds like something straight out of a science fiction movie, but the logic is sound. A well-placed explosion could theoretically alter an asteroid's trajectory enough to avoid a collision with Earth. Over in Japan, the Hayabusa 2 mission has already demonstrated the ability to rendezvous with an asteroid, land on it, collect samples, and return to Earth. This technology could be adapted for asteroid deflection by, for example, installing thrusters on the asteroid to change its course. These technologies give us hope, but the threat of asteroids is far from eliminated. The universe is vast, and we're just beginning to understand the complexities of asteroid behavior. But with continued innovation and international cooperation, we're taking steps in the right direction. The goal here isn't just to survive, but to thrive in this cosmic neighborhood we call home. As we look to the future, the challenge of asteroids remains. In the cosmic game of hide and seek, finding these celestial bodies is only half the battle. The real challenge lies in deflecting them, a task that requires relentless innovation and technological advancements. International cooperation will play a crucial role in this endeavor. United, we stand a better chance of protecting our planet. It's a task that transcends national borders and political differences, demanding a global unified approach. Moreover, the need for continuous technological innovation cannot be overstated. We must constantly push the boundaries of our capabilities, developing more precise detection systems and more effective deflection strategies. And while these tasks may seem daunting, we must remember that they are not insurmountable. After all, we've achieved incredible feats before, from landing on the moon to sending rovers to Mars. The future may hold many challenges, but our survival could depend on how we meet them. So where does that leave us in the face of the asteroid threat? Well, we've traveled quite a journey together, haven't we? We started off by acknowledging the looming danger from the cosmos, the asteroids. Then, we retraced our steps back to the time when humans first discovered these celestial wanderers. We delved into the advanced systems we've developed to keep a watchful eye on the sky, tracking and monitoring these potential threats. We also explored the innovative strategies that have been proposed to deflect or disrupt an asteroid's trajectory, potentially saving our planet from a catastrophic impact. Then, we looked at the cutting-edge technologies being developed to combat this threat, from laser beams to kinetic impactors. We also touched upon the future challenges that lie ahead and the ongoing research aimed at overcoming them. While asteroids pose a real danger, human ingenuity and technological advancement give us hope. We may not be able to prevent an asteroid strike, but our chances of survival are improving every day.